The sequence of diagrams above is made up of small lines and dots. Complete the table. To complete the table, we can just count the number of lines and the number of dots from diagram 5. However, since we don't have diagram 6, we can't do the same for diagram 6. It's a waste of time to draw diagram 6, so it's better to complete the table by noticing the patterns in the numbers. For the number of small lines, it goes 4, 10, 18, and 28. From 4 to 10, it's plus 6. From 10 to 18, it's plus 8. From 18 to 28, it's plus 10. Therefore, for the next term, we need to add 12. And for the term after that, we need to add 14. And since we have diagram 5, we can actually check the number of small lines in diagram 5, whether it is 40 or not. For the number of dots, the sequence goes 4, 8, 13, and 19. And from 4 to 8, we plus 4. From 8 to 13, we plus 5. From 13 to 19, we plus 6. Therefore, for the next term, we need to add 7 or plus 7. And for the term after that, we need to plus 8. For diagram n, find an expression in terms of n for the number of small lines. So what the question wants is for us to find the nth term for the number of small lines or the sequence 4, 10, 18, 28, 40, and 54. We already know the pattern of the sequence. It's plus 6, plus 8, plus 10, then plus 12. And the second difference is plus 2. Therefore, if the second difference is the same, which is plus 2 for all the terms, we know that it's a quadratic sequence. A quadratic sequence is always in the format an squared plus bn plus c, where a equals the second difference, which is 2, divided by 2, which equals 1. Therefore, for this sequence, a equals 1. To find b and c, we can substitute the known facts about the sequence into the equation n squared plus bn plus c. For example, we know that when we substitute n equals 1, it must equal 4 because the first term is equal to 4. And when we substitute n equals 2 into the expression n squared plus bn plus c, it must equal 10 because the second term in the sequence is equal to 10. And now we have two equations we can solve simultaneously for b and c. We can rewrite these two equations into b plus c equals 3 and 2b plus c equals 6. Since the coefficient or the number in front of the c is the same, we can minus the two equations to get rid of the c and get b equals 3. Once we have b equals 3, we can substitute b back into any equation to find out c. And now that we have the value of b and c, we can just substitute it back into our expression n squared plus bn plus c to get n squared plus 3n plus 0. Therefore, our nth term is n squared plus 3n. Diagram R has 10,300 small lines. Find the value of R. From part B of the question, for n equals diagram number, the number of small lines equals n squared plus 3n. Diagram R has 10,300 small lines means that when n equals R, the number of small lines must equal 10,300. And we know that we have an equation representing the number of small lines, which is n squared plus 3n. Therefore, 10,300 must equal n squared plus 3n. And we know that this value happens when n equals r. Therefore, we can substitute n with r. And now we have an equation in terms of r that we can solve for r. And we can solve for r by doing factorization. After solving for r, we have two values for r, which are minus 103 and positive 100. Since r represents the diagram number, it cannot be negative. Therefore, the r that we are looking for is equal to 100. For these questions where we are trying to find what term it is or what diagram it is, we can also do trial and error. Because what we want is an r value that when we substitute into r squared plus 3r, it must equal 10,300. So, if we try r equals 50, this gives 2,650, which is too small. Therefore, we want to try something bigger than 50. Then, if we try substituting r equals 200 into the expression, we get 40,600, which is too big. Therefore, we want to try something that's smaller than 200 but bigger than 50. So if we try r equals 100 and substitute it into the expression, we get exactly 10,300. Therefore, r equals 100 is the answer. The number of dots in diagram n is an squared plus bn plus 1. Find the value of a and the value of b. From part A of the question, we already completed the table and the number of dots for up to diagram 5 and diagram 6. So what the question is saying is that an squared plus bn plus 1 is the nth term for this sequence. If it's the nth term for this sequence, this means that if we substitute n equals 1 into that expression, we should get 4. And if we substitute n equals 2 into the expression, we should get 8. And now we have two expressions in terms of a and b that we can solve simultaneously. There are many ways to solve simultaneous equations. In this question, we are going to rearrange one of them for b and use it to substitute it into the other one to find the value of a. And once we have the value of a, we can substitute it back to find the value of b. So now we have a equals a half and b equals 5 over 2. Because the answer is a fraction, some of you might think that you made something wrong or you made a silly mistake. But there's a way that you can check whether your answers are correct or not by substituting a and b back into the expression an squared plus bn plus 1 and checking whether it works or not. And if you look at diagram 3, there are 13 dots in diagram 3. This means that when we substitute n equals 3 into the expression, we should get 13. And indeed, we do get 13. Therefore, our expression or our answer for a and b should be correct. And if you want to double check it again, you can also check it for the next diagram, which is diagram 4. This means that when n equals 4, the number of dots should equal 19. So if we substitute n equals 4 into the expression, we do get 19. Therefore, you can be very confident that your answers for A and B must be correct.